maximum maintainability in test automation. And the agenda will contain 4 parts. First will be the test automation frameworks history. After that, we will discuss some of the common problems in setting up testing frameworks. Then we'll have a look at some ways how to simplify your tests. And finally, I'll outline some suggestions on how to achieve maximum maintainability. In this presentation, I will concentrate on JavaScript frameworks as they are developing very rapidly while gaining more and more popularity. Before we start, a few words about me. I have over a decade of experience in test automation, quality assurance, and software as a service industries, skilled in end-to-end load and API test automation. During my career, I led quality assurance automation for a platform of 60+ highly scalable web applications and services, built and maintained numerous test automation frameworks, managed distributed teams of QA automation engineers, mentored and helped to convert manual test engineers to test automation. You can often find me creating and open sourcing new test automation frameworks, mentoring other QA engineers, or exploring new tools and techniques for test automation. In addition to that, I wrote a book called Modern Web Testing with TestCafe, a non-nonsense guide to getting started quickly by building a complete test suite while learning the core concepts of test automation with TestCafe. But enough about me. Let's briefly review the recent history of JavaScript test automation frameworks. So, in 2004, Selenium was created. After that, in 2005 was a year of WebDriver creation. And in 2009, both of them merged into Selenium WebDriver. Then, in 2011, the first version of WebDriver IO was released. And in 2012, World Wide Web Consortium started working on a centralized WebDriver protocol. In 2013, the first version of Protractor emerged. And 2016 was the year when TestCafe was actually released. Then, in 2017, Cypress opened a public beta, and in addition to that, the first version of Puppeteer was shipped. In 2018, Selenium WebDriver became an official World Wide Web Consortium recommendation for browser automation. And finally, in 2020, the first version of Playwright got released. So as you can see, quite a history for JavaScript and test automation there. That was some historical intro, and now let's have a look at the common problems that usually arise while setting up test automation frameworks. So let's begin from the framework selection. And the first problem we'll face is the variety of frameworks: Selenium, TestCafe, WebDriver IO, Cypress, Protractor, Playwright. What to choose? Let's have a look at one of the most popular metrics, the amount of stars on GitHub. Here's a nice graph to illustrate that. As you can see, even though Selenium is the World Wide Web Consortium standard and is the oldest among the listed, it still got less stars than two newcomers, Cypress and Playwright. Let's see how they do in terms of weekly downloads on NPM registry. So as you can observe, the bar charts are pretty impressive, but still they do not exactly correlate with the amount of stars for each repository. For example, Playwright has a ton of stars on GitHub and is growing rapidly, but for now, it has significantly less weekly downloads than all others. So, what else can we use to make an informed decision about the framework? Let's dive a bit deeper to see what features are offered by frameworks. As you can see, each of the frameworks has its own strong points, for example, the ease of initial setup. And in addition to that, each of them has some trade-offs, like ability or inability to work with multiple browser tabs. And that's absolutely fine. The thing to know, though, is the overall future direction of development for each particular solution. So, how to make a choice within such a variety of options? The final algorithm for test automation framework selection can somehow look like this. Firstly, review the framework repository on GitHub. How popular it is? How often does it get updated? How active is the community? What is the amount of open issues and how fast the bugs are being fixed? Then, look at the list of features provided by the framework itself. After that, browse through the list of possible trade-offs and think over if that is something acceptable for your particular project. And then, make a proof of concept with a set of simple tests and present it to the team. This way, you have ability to gather all opinions and feedbacks to make a final decision. So, the framework is selected. For example, it can be TestCafe, and we can start writing tests. As their number will be growing quite fast, let's see how to make the process more simple and enjoyable. What do you think about such line of code? Looks quite fancy and smart, but not so easy to understand, right? How about now? Becoming even more complicated? One nice thing to do is not to chase the shortness of your code. Usually, it's much more beneficial to apply convention over configuration approach to keep things as simple and readable as possible. Here is a better solution. As you can see, even while it takes 3 lines instead of just 1, the readability is much better now. By writing longer but more transparent code, you can help everybody who will be reading it afterwards to get a better idea on what's going on and to do it much faster. Let's have a look at several more examples of good practices. So, here is a function, and as you may notice, its main potential problem is the outcome that it creates. There can be 3 different sets of actions that will be executed depending on the incoming string. Looks like a Swiss Army knife. It can do whatever you want as long as you remember all the options and the internal logic. Doesn't look like a fun thing to test such code though. And if at some point one of the scenarios will change, that can be a potential headache. So, what can be done to improve such poor code and to make it more maintainable? That's where the granular atomic functions come into play. It takes a bit more time to split the code at the beginning, but on a long run, you'll get a set of small self-descriptive functions that are reusable and quite easy to change if needed. As most of us are working in groups and share the code base with teammates, let's have a look at how to raise the maintainability of our test automation code. Let's talk a bit about pull requests. Have you ever reviewed a pull request containing more than several thousand lines of code? How fast was that? How much time did it take to finally merge it in? Sometimes it's just unavoidable. For example, when adding or updating dependencies and rebuilding package log JSON. But as a regular practice, it's much easier to review several small and descriptive pull requests than to deal with one huge monolithic change. So, a good approach here will be to push less code, but more often, and to keep each of the pull requests lower than 400 lines of code. And remember, there is no such thing as a perfect software. It's always a teamwork to discuss and iterate on improving each particular piece of code. So, the test automation code was created, reviewed, and merged. Is this the end? Not really. One of the most important parts is documenting the changes. It is especially important if you are working in a group and contributing to some kind of a centralized testing framework. Usually, a good practice will be to document and spread the word about the new features that were merged and now can be used by everybody in the team. So, add some documentation to your functions. JSDoc can be really useful for that. And then, send a short message to your team, informing your colleagues about the new functions and elements that they can reuse from now on. This way, you're helping your teammates to spend less time inventing their own approaches to the same problems. At the end of the day, it's all about the teamwork. After writing a fair amount of tests, you eventually stumble upon a question: how to make a test automation solution scalable and maintainable on a long run, how to avoid code duplication and enforce reusable components. We can create a separate package and move all main actions there. But what will happen if at some point there will be a need to change the testing framework? All of those functions will have to be edited or even rewritten from scratch. Sounds like a tough challenge, right? One possible way to deal with that initially is to introduce a layer of abstraction. And if it can be self-documented, that would be even more awesome. So, what tool can we use to get it right out of the box? I'm pretty sure most of you have heard about it. It's Cucumber. And among others, there are 4 advantages that it can give us. Better documentation, available for all team members. Both developers and product owners will have the possibility to easily read your tests step by step. Single place to keep test functions and step definitions. This way, you can easily switch testing frameworks without rewriting tests. And you have to do it to rewrite step definitions for the basic actions, and all the tests will be green again. More modularity and code reusability. Now the tests will be stored in feature files and will look just like the lines of text, one action per line, with given when and then. Test files separated from testing framework. You'll have a separate folder with all tests or feature files, as Cucumber names it, and a separate folder for all step definitions. So, here how the code comparison will look like. From the left side is a simple test written with pure TestCafe. And from the right side, you can see the same test written in Cucumber steps with TestCafe under the hood. What it does is just going to the Google's products page and verifying its title. Looks much more structured, almost like a documentation, right? But where is TestCafe, you'll ask? Here how step definitions look like. As you can see, they are pretty atomic. It gives us the possibility to combine and reuse such steps to perform any actions on a page. And at the same time, our test files look almost like step-by-step documentation. It works in a pretty simple way. When you launch the tests, Cucumber parses your feature files and then executes the TestCafe code corresponding to each line of the text in the feature file. Another nice thing about Cucumber is that we can use data tables to execute the same test, but with different sets of elements. As you can see, in the file, we have only one test scenario, but underneath it, there is a table with additional sets of elements. This way, the same test will run for each line of data in the table. So, this test will be executed 4 times. Each time, it will take page name, link, and words from the next line of the table. If you're thinking that it looks fun, but you don't want to write all the step definitions for each basic action, that's totally understandable. That's why I wrote an absolutely free and open source package that provides all of those basic steps for you. This TestCafe Cucumber Steps package has 42 step definitions that covers pretty much all basic steps to interact with web elements, and verifications are also built in right out of the box. Plus, you can easily extend it with your own steps if needed. In addition to that, it is officially listed among the plugins in TestCafe documentation, so check it out. It's quite easy to install and use. Also, in my GitHub, you can find the same set of predefined steps for Protractor, and I'm currently building the similar step definitions package for WebDriver I/O. This way, we will have an additional luxury, the ability to easily switch tests from Protractor to TestCafe or WebDriver I/O if the need will arise. That's it, folks. I hope you enjoyed listening to my thoughts today. Please feel free to reach out. I'm always ready to discuss interesting ideas and approaches.
We can now move ahead to the Q&A session.
Okay, how easy is it for team to adopt BDD or use of Cucumber? I would say that it's not that hard actually. It mostly depends on which stage you're integrating it. If it's an early stage, then it's really like an ideal situation. Then you just start defining your steps or using some existing package. And it's more about the process, how you set up. So Cucumber gives you a possibility to centralize your steps. And if you're working in a team on a large scale, I mean, if you have at least maybe 3-4 automation engineers who are working on the same code base, then Cucumber automatically gives you the possibility to keep everything separated in a separate package or repository. And it makes all your automation engineers to reuse the same steps. So there will be no inventing of a bicycle or something like that. Everybody will, if needed, they will add new steps to this centralized package and inform all others that, hey, here is a new step, you can reuse it now. This way, everything will be clean and you will need one solution as a source of truth. So yeah, the short answer is it's not that hard. It's more about how you set up the process. Have you looked at any other frameworks after working with TestCafe plus Cucumber, something like Karate framework? I haven't looked at Karate. I was looking into Protractor, WebDriver I/O, TestCafe, Selenium itself. Yeah, so I suspect that Karate is pretty much the same because like all JavaScript frameworks have one idea at the core of them. It's more about how each of them are performing on top of it and what are their additional benefits, what are their additional features, and what are their limitations, because each framework is good for its own set of goals, and one is better than another in this particular sphere. So you have to evaluate for your particular project what features you will need and with what limitations you can live. Your preferred order among Cypress, TestCafe, and Playwright. I can say that I prefer something more over another. It's more about what goals, what problems are you solving in your current project. Each of them has their own strong sides and their own weak sides. So it will really depend on each particular project that you want to use. Can you state the advantages of JavaScript frameworks over traditional frameworks? I would say that the main advantage is JavaScript itself, because we're testing browsers, right? And JavaScript is a browser language. It was initially developed to operate within browsers and with browsers. So the advantage is JavaScript, and if you tried other programming languages, for example, and Selenium with them, they have always evaluate functions that help you execute JavaScript in browser. So this way you're writing, like, for example, Ruby or Python code, and then from time to time to apply some more advanced logic, you have to evaluate JavaScript. In JavaScript frameworks, you're writing JavaScript and you're evaluating JavaScript, which gives you like more into one stack of technologies. Plus, with newcomers, with two modern frameworks, even three, I guess now. So with TestCafe, Cypress, and Playwright, they are closely tied to the browser itself. For example, TestCafe and Playwright, they are kind of injecting their code into the browser. So it gives you additional nifty thing about the speed. They work a bit faster than the traditional Selenium setups. Can you state the advantages? Okay, that's one. What features does TestCafe provide instead of Selenium? Yeah, so TestCafe is nice from several perspectives. It basically is really easy to install and use. It's quite nifty written in terms of the amount of features that are provided right out of the box. For example, usually in ideal situation, you want to launch your application locally or inside of a Docker container somewhere on some kind of a port. And then you want to run your tests over this application and then kill it. With standard Selenium solutions, you have to write this logic of launching the app, then running the tests and killing the app yourself. There's no, as far as I know, provided right out of the box Selenium solution for that. TestCafe gives you this from the beginning with a simple flag ---- app. You can just specify the script to run, or basically the bash command to run, and it will be executed before your steps. Then the steps will run, and then it will go automatically turn down, which is quite nice. And a lot of test automation engineers are using it. It's just to name one of many. So if you open TestCafe documentation, or at least get started guide, you can have a look at what they have inside. The configuration is pretty nice. And what is also great is that most of the properties from your configuration files can be additionally configured or even overridden with the flags. So you can keep your configuration. And then for some environments, you can override this configuration with additional flags. What would you say to team members that are traditional in their mindset? How would you convince them to use BDD? Yeah, so it really depends on each particular team. But usually, if your team is more or less big, you stumble upon the problem with code duplication, which means that basically, even if you have one portal, but each of your test automation engineers are working on a separate pieces or subsections of this portal, eventually they will have to write similar code because some of the actions are really similar throughout the portal. So the best solution here is to somehow keep it in one place and make everybody reuse this one way of writing things, because if something will get updated from the browser side, for example, if there will be some bugs, then the team will have to fix in lots of places. If you keep everything in one place, in one package, you just push one update, all other guys just pull it in, and it works perfectly again. Okay, is it worth investing to migrate to JS-based framework from current Selenium-based frameworks, since current one is flaky and running quite slow? Yeah, I mean, you still have to evaluate all the frameworks that are currently on the market to see the whole list of features and to compare. Also, I would suggest for you to basically take, for example, your current setup and take one or two modern JavaScript frameworks and do a small example set of tests in all three of them, and then run them maybe in parallel, how you usually prefer to run them on your CI/CD, and to compare what is more stable, what is the amount of code that you write, and what are you more comfortable with. This will give you more or less fair idea on should you switch or you're still okay with your current implementation. Is there any limitations of TestCafe? Yeah, for sure. As with every framework, there are some limitations. For example, TestCafe had no support for multiple tabs, but they rolled it out like several months ago in beta, and it was actually quite stable, surprisingly. And now they're rolling it out as a full-fledged feature. So they're catching up with all the stuff that you need. And I would say that they've done really impressive work. So they're in a good state now, and it's absolutely stable. You can absolutely use it for most of your tasks and goals. What would you say to team members? Okay, this one already answered. Any thoughts about WebDriver.io? Absolutely. WebDriver.io is a really neat thing. It has Selenium underneath of it, which adds additional kind of limitations, but at the same time, not so long ago, they rolled out possibility to switch to Puppeteer under the hood, which basically eliminates the need for Selenium server and helps you to basically interact with browser more directly, more fast. So WebDriver.io is really a nice example of a framework that is quite old and stable. At the same time, they are constantly evolving and they're integrating new features, which definitely is a nice thing to do. And they have an amazing community, very supportive, and yeah, it's quite stable and good framework, I would say.